What's going on, guys? In this video we are going to see how to solve these systems of differential equation. Here we have x double prime is equal to y and y double prime is equal to x. The first thing is we have to rearrange this one like x double prime minus y. I brought this y to this side, that's equal to 0, and y double prime minus x is equal to 0, but I keep the x terms in front, so this is going to be just negative x plus y double prime is equal to 0. Then we have to write this one in terms of d. If we write this one in terms of d, since this is the second derivative, we put d square for that, multiply by x minus y is equal to 0, and for the second one minus x remains the same, plus d square y, because second derivative d square y is equal to 0. Here we have to get rid of one of these terms. We can get rid of x or we can get rid of y. Here I'm going to get rid of this x. To get rid of x, what we have to do is we have to multiply this one by d square and we can add them together. If we multiply this one by d square, this is going to become negative d square x plus d power 4 y, and in the other side d square times 0, that's going to be just 0. And here you can see this is our first term, this is our new derived. Let's say this is second equation, this is first equation, this is third equation. Here we are adding 1 plus 3, 1 and 3. If you add them together, you can see d square x and this negative d square x cancels each other. So we will get negative d power 4 y minus y is equal to 0. Okay. Now if we write this one in terms of derivative, this is fourth derivative, because d power 4 multiplied by y mean this is fourth derivative, y power, well, like fourth derivative minus y is equal to 0. And if you write this characteristic equation for this one, this is going to be just m power 4. Since we don't have any derivative here, it means we just have to put the coefficient. Minus 1 is equal to 0. Now here we can factor this one like m square plus 1 and m square minus 1. M square minus 1 is equal to 0. From this one, if we solve for m, this is going to be plus or minus I, and for this one it's going to be m is equal to plus or minus 1. Let's continue here. So plus or minus plus or minus I mean this is a complex number, and here this is distinct real roots. We have plus 1 and minus 1. So let's write the general solution of y of t. General solution of y of t, because y is the only term remaining, so the solution is going to be in terms of y. Y of t is going to be, for the general solution, if we have distinct real root, the pattern for the general solution will be like this. We will have a constant e power minus t plus c2 e power t, and then if it's a complex number, here this is alpha, alpha is 0, beta is 1, this is our beta, this is 1. So e power alpha x mean e power 0 is 1, so we don't have to write that part. We just have to write the cos beta t and sin beta t. In our case, beta is 1, so this is going to be cos t plus sin t. And we have to have a constant c3 c4. Now we found out y of t. Now the next thing is, in systems of solution we have to find out x of t. Like we have found out y of t, but we have to find out x of t too. To find out x of t, you can choose any of this. You can choose this one, this one. Here we have y of t. To find out the x from this one, in the second one, you have to take the second derivative of this y. But if you choose this one, to find out the x, because we already have y, if you integrate this one twice, you will get y is equal to x double prime. It means this one is already equal to x double prime. So if you integrate this one twice, you will get x. But this one looks much easier. If we take double derivative, this one gives us the x value. Okay, let's take the first derivative, y prime. That's going to be negative e power negative t. If you take the derivative, negative multiply in front, negative c1 e power negative t, and then c2 e power t, that's remain the same if you take the derivative. And then cos become negative sign, so minus c3 sin t. And if you take the derivative of sine, that's going to become cos. So this is going to be c4 cos t. Now this is first derivative. Here we know that x is equal to y second derivative. So we have to take the derivative again. y double prime, that's equal to x of t. That's what we are trying to find. Now let's take the derivative. E power negative t derivative minus multiply, this will become plus, minus minus plus, e power negative t, then this one remains the same, c2 e power t, and if you take the derivative sign, that's going to be just cos, minus c3 cos t, and if you take the derivative of cos, that will become minus sine, so c4 negative sine t, so negative I already put it right here, so this one will be just sine t. Okay, now we took the second derivative. So this is our x of t. We found out y of t. Y of t is here. And we found out x of t, that is here. Okay. But here they have given the initial values. So we have to find out what is this, what is this c1, c2, c3, c4. And then we have to write the final solution in terms of that. Okay. Now let's see how to find that. First, I take this y of t and x of t. We have these two terms. We are going to need some space for that. Let's get rid of these things. Okay, let's get rid of this one. First of all, we know that x0 is 3. It means when the time is 0, this is equal to 3. Let's grab this x function. We solve for x of t is equal to c1 e power negative t plus c2 e power t minus c3 cos t minus c4 sin t. Okay, now we know that when the time is 0, this is equal to 3. So if we put x of 0 and plug 0 for all the t values, this is going to be just c1, and this one becomes c2 because e power 0 is just 1, and cos 0 is also 1, so minus c3, sin 0 is 0, so the whole thing will become 0, so we can neglect this. And we know that x of 0 is 3, so the 3 is equal to c1 plus c2 minus c3, and then we know that y of t is this one. Let's go ahead and plug the y of t values. Y of t is equal to c1 e power negative t plus c2 e power t plus c3 cos t plus c4 sin t. Okay, now we know that y of 0 is 1. Let's plug that one here. Y of 0 is c1 e power 0 is going to be just 1, and c2 e power 0 is again 1, and cos 0 is going to be just 1, so c3, and then sin 0 is going to be 0, so the whole thing is going to be 0, and we know that y0 is 1, so 1 is equal to c1 plus c2 plus c3. Okay, let's say this is equation number 1. Let's say this is equation number 2. If we add them together, this c3 terms will get rid of. 1 plus 2, we will get 4 is equal to 2. We will get 4 is equal to 2c1 plus 2c2. Okay, therefore we know that if we divide everything by 2, 2 is equal to c1 plus c2. So we have c1 and c2 value. Okay, let's see what we can find from that. We have c1 and c2 value and x prime of 0. Okay, let's see whether we can find something from this. We have c1, c2, and let's take the derivative values. Y prime we already have here. We already have this one. Let's plug this 0 for this one and see what we get. Okay, I take this function y prime is equal to negative c1 e power negative t plus c2 e power t minus c3 sin t plus c4 sin t. Now y prime of 0 is there, so if I plug 0 for time, y prime of 0, then this is going to become negative c1, and this is going to become just c2, and sine will become 0 because sine 0 is 0, so c4 will c4 cos t. this one is cos. This will become 1 because cos 0 is 1, so c4 will remain. And we know that y prime of 0 is given, that's negative 1. Negative 1 is equal to c1 plus negative c1 plus c2 plus c4. Now we have found out y prime of 0 and also we have x prime of 0 available. So let's check the derivative of this one. X prime of 0. X prime of t is going to be negative c1 e power negative t plus c2 e power t, and if you take the derivative of cos, that's going to be minus sign, minus minus become plus, so plus c3 cos t, and the derivative sign is cos, so that's going to be just minus c4 cos t. Now we know that x prime of 0 is 1. I'm going to plug x prime of 0. Instead of time I put 0, so this is going to be just negative c1 plus c2 plus, if we plug 0 for cos, that's going to be just 1, so c3, and this is going to be sine. Sine 0 is 0, so this is going to be just 0. And x prime of 0 is 1. 1 is equal to negative c1 plus c2 plus c3. Okay. Now we have these two things. Okay, we have this one and this one. Let's see how to, we have c1 plus c2, and here we have these two terms, minus c1 minus c1, c1 plus c2 plus c3. Okay, let me double check this. If you take the derivative, first derivative, c3, this will become sine t. Derivative, of course, I did a mistake on derivative. Okay, let me do it again. Okay, x prime of t, negative c1 e power negative t, c2 e power t. If you take the derivative of negative c3 cos t, derivative of cos is sine. So this is going to be c3 negative sine, so this will become plus sine t plus minus c4 cos t, derivative of sine is cos, c4 cos t. If we plug 0, this is going to be, c3 is going to be 0 because sine 0 is 0, so c4 is going to be just negative c4 because sine cos 0 is 1, so we will have this one, and this one is negative c4. Okay, now let's say this is equation 3, this is equation 4. If we add 3 and 4, you can see this c4 terms cancels, and we will end up with 0 is equal to negative 2c2 c1 2c1, and c2 that's going to be plus 2c2, and c4 minus c4, those going to be cancelled, so we will get this one. Okay, now we have got this one, and if we simplify this one, if we divide everything by 2, this is going to be 0 is equal to negative c1 plus c2. Okay, now we have these two terms. Let's call this one equation number 5, let's call this one equation number 6. If we add these two together, 0 is equal to negative c1 plus c2, this is going to be just 2, and this is going to be 0. So c2 is equal to 2. We found out c2 is equal to 2. And if you plug c2, let's double check. c2 is equal to 2. Okay, let's see what we get for c1. c1 plus c2 is equal to 2. There's a mistake here. Let's double check. c1 c2 minus c3 is 3. c1 plus c2 plus c3 is equal to 1, and then c1 minus c2 okay, that's equal to negative 1, and this one is positive 1, and when we simplify we get 2c1 minus plus 2c2 is equal to 0, minus c1 plus c2 is equal to 0. Okay. Okay, let's double check. 2c2 is equal to 2c1. 2c2 is equal to 2c1. Okay, from this one, okay, I made a mistake here. From this one we can say 2c2 is equal to 2c1. 2c2 is equal to 2c1. If it's true, then instead of adding like this, we can put, okay, we can put 2c2 is equal to 2c1, so 4c1, because 2c2 is, instead of 2c2 we can plus 2c1, so 4c1 is equal to 4. 4c1 is equal to 4, therefore c1 is equal to 1. If c1 is 1, then c2 also 1, because instead of 2c1 we can also plus 2c2. So 4c2 is equal to 4, therefore c2 is also equal to 1. If c1 is equal to 1 and c2 is equal to 1, then we can solve for c3 and c4. If we plug c1 plus c2, c1 plus c2 is 1 plus 1, that's 2. So 1 minus 2, c3 is going to be negative 1. And let's look at c4. c4 here, c1 is minus 1, minus 1 plus 1, that's 0. Negative c4 is equal to 1, so c4 also is equal to negative 1. Now we found out everything, so we can express our final answer like a particular solution. Final answer as particular solution. Okay, let's get rid of all these things. Okay, we have y of t. Y of t is equal to c1 e power negative t. c1 is 1, so this is going to be just e power negative t, plus c2 is 1, so this is going to be just e power t, and c3 is negative 1, so this is going to be negative cos t, and c4 is negative 1, so this is going to be negative sin t. This is our final solution for y of t. Now let's write the final solution for x of t. For x of t, c1 is still 1, so this is going to be just e power negative t, plus c2 is 1, so this is going to be just e power t. c3 is negative, so negative, this is going to become positive cos t, positive cos t. c4 is negative, so this is going to be negative positive sin t, and this is the x of t solution. And that's how we do that. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.